Welcome everyone to another posting for the Iowa Local Agency Bridge Innovation and Demonstration Days. This one will be about concrete bridges. I'd like to introduce Brian Kylieber, the Buchanan County Engineer. Typically when we are in Buchanan County, we do a tour of the different kinds of bridges: concrete, steel, rail car, and wood. And Brian's going to be commenting on this video, and there should be 4 of them posted on the website that I encourage you to look at. So Brian, go ahead.
Well, hello and good day, I better say. At any rate, we're going to start out here with cast on site slabs. This one in particular, box beams or slabs have been a very common staple in many of the rural communities. This was some of our efforts to try some, and I was really, my goal at the time was to develop a way that I could build bridges without the use of a crane. So the substructure on this one's really what's unique and innovative, in the sense that I used GRS IBS. I had the gentleman stack it on a 2-to-1 slope on the face. It's 3-to-1 on the side slopes. And so they stacked my fabric on a 2-to-1 face. Now that was a little challenging. They had to actually put up some boards as they were bringing up the fabrics. And we did a burrito wrap on the GRS IBS. And so what you're seeing there was that roller compacted concrete that I faced it with. And when I say roller compacted concrete, when asphalt prices had gotten so high a few years back, in many of the southern states, they were looking for ways to be able to place the concrete with their existing equipment, and they developed a roller compacted concrete mix to run this through the asphalt equipment. And so what we did is we stacked this on the 2-to-1 slope and packed it in place with a vibratory plate packer on an excavator. The slabs, as we were talking about, were actually built off on the approach roadway, and my goal was to drag them into place. Now you see a little bit of cracking there, but I do have number 4 rebar at 2-foot centers to tie everything together. If it ever does start giving me an issue or a problem, I could come back in with gunite or something to face it. The fabric, the only purpose of the roller compacted concrete is to keep the sunlight from ever seeing the fabric. They tell me the fabric will last about 500 years if it doesn't see the sun. This is the surface on the deck, and again, these were slabs. My goal was to pull into place, and I was, in their efforts of making arrangements, I brought out a smaller wrecker, and he went to pick them up, and the front end of his wrecker was coming up, and he could have moved them. I was going to put rollers underneath him, but he got nervous about pulling it across the water for fear that it would pull him across the water. So he ended up bringing a crane and setting them. And now we're moving on to another one. This is a box beam bridge that was constructed by, this is part of the contract, the bridge bundling contract that Brian Moore has talked about earlier in this conference. And this here one is tied together. The slabs were prefabricated, brought out, and tied together with ultra-high performance concretes. You'll also notice that the barrier rail sections, and here's the deck, here's our joints. I did have a couple of them. I've got a fair amount of experience with ultra-high performance concrete, and we did have a little more shrinkage in this than I was anticipating. So it's every day's a learning experience, and I truthfully learned on this. Again, this is the SL1 guard barrier rail system, which is a bolt-on rail system. This is standard stub abutments, basically, where we drove H-piling and poured the concrete cap on it and poured the wings off of there. And you can see the SL1 barrier rail bolted in there. And again, a very nice, this is 50-foot slabs. That's about the maximum you can take these box beams, and they are voided in there. They've got insulation to void them out, but without post-tensioning or pre-stressing them. And the joints underneath are very nice and clean too. Very economical bridge, as I mentioned earlier. The box beams have been one of the staples in many of the rural communities, and we're looking for a better way of producing these and keeping them going. You can see the other view of that structure again. And the rail system, this here has federal funds in it, and that kind of dictates how I handle my approach sections. And even though it's 30 wide, and many of my other structures are 30 wide, what we're doing here is moving into the first ultra-high performance concrete bridge. This here happens to be the Jakeway Park Bridge. This is a pie beam bridge constructed in about 2008 on this particular structure. It was the first pie beam bridge built. And I really need to thank the Iowa Department of Transportation and Federal Highway Administration for giving me the opportunity to work in there. You notice that deck is only 4 inches thick. And in theory, it could have been 3 inches thick. And then after some testing and analysis that they did at the Turner Fairbank Labs, determined that they should probably go to a 4-inch thick deck, but that's just a 4-inch thick deck. Again, it's got the SL1 barrier rail system attached to it, and it's a pie beam shape. They're looking for the most efficient and economical way they could utilize this ultra-high performance concrete. The concrete itself, they use a design strength of about 21,000 PSI for a design strength on that. Now what we did in here is we put 2 slab sections in as approach sections on this bridge, and we designed it as simple spans, all 3 of them. But again, that's the Jakeway Park Bridge. One of the interesting things, if you notice in the background, the livestock there, and there is 2 unincorporated villages that used to exist at this particular location. And at the time we were getting ready to build the bridge, they were doing archaeological digs there. And there are individuals that were saying, "Brian, you'll never get through your permits." And I said, "Oh, I know the area well, I'll get through them." The reason I knew that is because they had the noisiest bulls I've ever seen. This happens to be the Hawkeye Bridge, which is ultra-high performance concrete also. It's a partnership with the Korean Institute of Construction Technology. They sent about 5 engineers over from Korea and the materials, and with the county employees, we constructed this ultra-high performance concrete pie beam bridge. And I would have not had the knowledge or experience to build this had it not been for the previous work with the Jakeway Park and the experience we'd gotten there. But Dr. David Lee is one of the key people on this structure. Now, some of the things that are a little different on this is we ended up post-tensioning these UHPC beams, and we also transversely post-tensioned them too, and then grouted and sealed it off. But this here is the Korean concrete bridge, is kind of what we know it by, and otherwise known as the Hawkeye Bridge. We'll get to the Cyclone Bridge later. And so you can see again the SL1 type barrier rail system. You'll see the post tensioning across there. You'll see some of the little marks from our forms. And again, this was all done with county employees. Alex Davis here in my office, actually, the licensed assistant, actually constructed it. We use a lot of the sheet piling and tie the wings on with the sheet piling. This is on H piling, and stub abutments is the basic design on this bridge. I mentioned earlier about the desire to find a way that I didn't have to have a crane, and vibratory H piling drivers like Todd Kenny and some of the others I've talked about are just really filling that need to move away from having to have a crane on site. When I come to set in some of these bigger units, I can hire a crane to come in for the day, much more efficient and economical than I could possibly own one. If you notice again, that's the surface of the UHPC where it's not covered with road rock, and it is a very smooth surface. The UHPC itself is self-leveling, self-consolidating, so that presents little challenges in ways. And if you need the texture, and we'll get to that when we get to the deck overlays, you can grind it and texture it then later. Again, we're using the SL1 barrier rail system on this, and this is the this is the Korean UHPC bridge, known as the Hawkeye Bridge. And you'll notice one of the things on the end rails, I don't have the terminal end sections on this because, again, the bridge is wider than the roadway approaching it. And it's done with local funds on straight sections of road, much like the design guides coming out of Kansas, where we've not had any accident histories. This is a bridge deck overlay that we did on Wapsie Access Boulevard, just outside of Independence here. And what we did is we took the state standard type O mix and put a super plasticizer in it. Now, this was done again in 1999 as part of a research project. We'd done this a couple times before with very good luck, and that happened to be in Palo Alto County. And so what we did is we came in, milled off the bridge deck down to good sound concrete, took out any of the unsound spots that we could locate, and did one lane at a time so we could keep traffic on it, milled it off with a milling machine, and then using screeds, and actually in this case I had flat work contractor rather than my own crews on this, put a super plasticizer in the Type O mix, mixed the Type O and ready mix trucks, brought it out and placed it on the bridge. It was done in 1999. The DOT and Iowa State University has done numerous tests on this, trying to evaluate the bond, how it was and everything. You can see the texture on this because we did tine it. And again, it was an 1.5 inch overlay, so we basically took off 1.5 inches and put back 1.5 inches. I did have some little problems even with one lane. We finished about 2:33 in the afternoon, closed things up, barricaded off one lane and had it stop, please alternate type traffic control. And a farmer happened to come down the road with a swather, had the traffic backed up quite a bit behind him. He was too wide to get across, but somebody was nice enough to move the barricades. And so he drove across the bridge, which left little indentations on it, even though it was only about 1.5 hours after it was all completed. And there was no, if you go back there today, you don't even find the little indentations so much. It was right in this area off to your left here is where that occurred. Again, this was done in 1999, so it's 21 years old, performing quite well. I know the rest of the bridge is starting to have some major issues underneath it in the substructures, but at least we bought us another 21 years out of this deck, and we'll get a few more out of it too. And again, this was the bridge on Wapsie Access. As it is now that the state's made improvements to the mix, and it is done on a regular basis, putting the super plasticizers in for the deck overlays. The Type O mix is 0 to 1 inch slump by standard until you put the plasticizer in there. So you're keeping your water cement ratio. Again, another one of the core spots that was cored out. I have had some problems with the repairs that were done that way, and I've had to go back in and seal them off again. The patches that they did where they drilled the holes didn't necessarily work. So we're always looking for better ways of doing things is kind of the answer. And I mentioned about having some issues underneath in the substructure. This is basically the state standard for, they have an option on it whether they want to go back and use a specialized equipment to place the Type O or this mix. This happens to be the next bridge deck overlay, and this here is the Brandon LaPorte Road. And this one's using the ultra high performance concrete. And you'll notice, again, the differences in the past, it was transverse tining, now it's longitudinal tining. And actually, when we say tining, it was milled in. So what we did is we poured one lane, and with the ultra high performance concrete. And again, it was the first one in the Western Hemisphere, so we were doing some learning. It was truly done with a vibratory truss screed. Now this bridge is on a 5.5% super, so what had to happen on that, and what we're showing right there is some of the little steel fibers that haven't worn off yet because the UHPC has steel fibers in it. And when they get exposed this way, they'll usually rust off fairly rapidly and deteriorate fairly rapidly. They're nasty little creatures when you're working around them. They'll jump in your pants and bite you. And 5.5% super. So what happens with UHPC in itself is generally self-leveling, self-consolidating. So Lafarge had to change the makeup of this and put some other additives in there to get it so we could put it on a 5.5% super. Part of the reason this bridge was chosen was for the deck overlay, aside from the fact that the bridge deck was going bad on it, was the fact that this was a good opportunity to see what we could do with the different supers. Now underneath it, the bridge had some problems too, and it was the concrete piling were rotting off at the water line too. And so we came back in and I did some repairs to that. This is one of my first experiences using this happened to be a Phoscrete product that we used on this one. And you can see where we had done some repairs. The guys liked it. In the past, I've done some other methods of repairing these piling, in particular where I brought down ready mix, and this was actually easier because of the quantities were so much less to get it underneath there and place it. Again, this was a slab bridge, and I want to put it in right around 1960 on the time frame for construction. So I've got 60 years out of it already, and I need to have a few more. And if we keep up the maintenance on it, we will. I know I've got some repair work on the hub guards. You can't see that in these views, but earlier you may have caught that. Also, you'll notice this is a very good habitat for barn swallows. They love these structures. And your older barrier rail type system. I've also had some issues where I did get water underneath coming through my abutments. We used a bunch of flowable mortar in there a few years ago and repaired that. I have heard of another county that didn't identify that soon enough and actually had their H-piling rust through underneath the stub abutments to where they had to come back in and weld in some. So anything you can do that way to maintain these bridges to your benefit to get more life out of them. And so if you look, piling repair, deck repair, it all comes together and extends the life on these bridges.